Well, hey there! Today we're going to be talking about how to find the lengths of missing sides in right triangles using right triangle trig. Now, usually if we're trying to find the length of a side in a right triangle, we use the Pythagorean theorem. That would be our classic a squared plus b squared equals c squared. To do that, we're going to need the lengths of two sides, either the hypotenuse and one of the legs, or both of the legs. Failing that, well, then I guess we're out of luck with our buddy a squared plus b squared equals c squared. If you can't use the Pythagorean theorem, don't worry, you're not out of luck just yet. If you know the length of a side and you happen to know one of the angles in the triangle that isn't the 90-degree angle, then you can use SOHCAHTOA to help you find the length of the missing side. Now, in these types of problems, you're going to be given an angle and you're going to be given two sides. One of the sides you're going to have a numerical value for, and the other one you're just not going to know. It's either going to be x or it's going to be some specified side. Your first job is to figure out how those two sides relate to your angle. Do you have one side that's the opposite and the other one that's the hypotenuse? That sounds a lot like sine. Do you have the adjacent and the hypotenuse? Well, that sounds like cosine. And then, of course, if you have the opposite and the adjacent, you'll be talking about tangent. Once you've determined that, then you're going to set up the appropriate trig ratio. That would be sine, cosine, or tangent of your angle is equal to the corresponding fraction from SOHCAHTOA. Then you have to solve for your variable. No matter what, you're going to be multiplying by the denominator first, but the rest of the work is going to depend on where your unknown side is. And you'll see exactly what I'm talking about when we get to the examples in just a second. All in all, it's not a really hard skill, but of course talking about it is a lot easier than doing, so why don't we go ahead and chop get to work. Alright, so in the first two examples here, we're asked to solve for x in our two triangles. The first one gives us an angle of 30 degrees, a side length that's 16, and an unknown side that's x. See how we don't have two numbered side lengths? That means that we can't use a squared plus b squared equals c squared. But on the bright side, since we do have an angle and we do know one of the two sides, we can use SOHCAHTOA to help us out here. So like we said before, we're going to start by determining how our two sides relate to our 30-degree angle. How you go about doing this is up to you, but I usually like to try and figure out which one is the hypotenuse first. It's always the longest side in the triangle and the one that's opposite the 90-degree angle. Now in this triangle, that specific side is going to be the 16 right here. We're going to label it as hypotenuse because that's going to help us stay organized later on. To figure out about adjacent and opposite, we highlight the angle right here. X is the opposite because it isn't part of the angle itself. Now, if you're having trouble remembering the difference, I like to remember it as A for adjacent, A for angle. The angle itself is always going to be made up of the adjacent and the hypotenuse, so once you know what the hypotenuse is, process of elimination gives you the adjacent side. Now, we don't have that in this triangle, right? In this case, we have the opposite and the hypotenuse, which means, if we're thinking of SOHCAHTOA, we need to use sine of our angle. So we set up our trig ratio. Sine of the angle is equal to the opposite of x over the hypotenuse 16. So, solving for x, we have to multiply both sides by the denominator 16. We punch that into our calculator. 16 times sine of 30 is going to give us a final answer of 8. X is equal to 8. Alright, so obviously one of the most important things here is that we correctly identify the sides that are given to us. If we don't identify those correctly, we're going to use the wrong trig ratio and we're not going to get the right answer. Remember, the angle that's given to you is always going to be made up of the adjacent and the hypotenuse. A for angle, A for adjacent. Once you know the hypotenuse, you know the adjacent, and therefore you know the opposite. Label your sides, check with SOHCAHTOA, set up the trig ratio, and then solve with your normal algebra. And with all that in mind, let's go ahead and check out our next example. Our task here is the same as it was before, solve for x. This time, we're given an angle of 71 degrees. We have a side length of 96, and then, of course, the other side is unknown. We call that x. We'll start by identifying our sides and labeling them as either opposite, adjacent, or hypotenuse. As you can see from the diagram, our hypotenuse isn't labeled with anything, so that means that we have the opposite and the adjacent side. Our angle is down here, and the side that makes up the angle is x. That means that x is the adjacent, and by process of elimination, 96 is the opposite. And now we ask what part of SOHCAHTOA uses the opposite and the adjacent. Well, that would be tan. So we'll do tan of our angle, which is 71, like so, is going to equal the opposite side, 96, over the adjacent side of x. Now, I know how tempting it is to want to multiply both sides by 96, but when we're solving and we want to get rid of a fraction, we always multiply by the denominator, in this case x. Those x's cancel out, and we have x times tan of 71 equals 96. Hard as it is to believe, tan of 71 is actually a number, and it's a number that's being multiplied by x. If we're solving and we want to undo multiplication, we divide. So to get x, we just do 96 divided by tan of 71 in our calculator, and that gives us approximately 33.06. All right, so obviously having x in the denominator makes a little bit more work for us in the solving process, but it's just one more step, right? Instead of just multiplying, we're multiplying and then dividing. So these two first examples are the only two variations on the type of work you're going to have to do for these problems. Sometimes, though, the problem is going to ask for what it wants in a slightly different way. For example, this one right here. Instead of just asking for x, it asks us to find AB. And if you see two letters next to each other without a line over them, you know that you're looking for the length of a specific segment. Regardless of how it's being asked, we're not going to alter our work in any way. First, though, we want to figure out where is AB on our triangle. Well, we're going to highlight it for ourselves so that we can see AB is this vertical side right here. It's the one that connects the letter A to the letter B. Go figure. As you can see, our 63 is the side that's opposite the 90-degree angle. That makes it the hypotenuse. Our highlighted side, on the other hand, is the other half of our 28 degrees. That makes it the adjacent side. And we ask ourselves what part of SOHCAHTOA is going to use the adjacent and the hypotenuse. That, of course, is going to be cosine. So we do cosine of our angle, which is 28 degrees, is equal to the adjacent side. We don't know that. We'll call it x over the length of the hypotenuse, 63. And check it out, with x in the top, that means that this is going to be the easy example. All we have to do to solve is multiply both sides by the 63, type that into our calculator, 63 times cos of 28, and we get 55.6 is approximately equal to x. And there you have it, folks. Label your sides, set up your SOHCAHTOA fraction, and solve for the missing variable. Remember that the hypotenuse is the longest side in the triangle. It's opposite the 90 degrees, and the angle that you're given is going to be made up of the adjacent and the hypotenuse. So once you know the hypotenuse, you know the adjacent, and you know the opposite. And that just about does it for now. Remember, practice, practice, practice. Thank you very much, and we'll see you next time.